Everybody, Mr. Rubo here. We are still in 314 polar function graphs. We're going to do example 4 here. And so this example is a great example of a multiple choice question you could see on AP test, on our test. And so what we have here is it tells you we have r equals f of theta, where f of theta equals 3 sine of 2 theta, which if you recall, that means this is a polar rose equation. But now they're telling us it's only shown from A to B. And they also tell us that A and B are between 0 and 2 pi. So it's somewhere in the unit circle, but we don't know what they are. And we need to figure out which of these values could be A and B, where we only get this part of the full graph, right? And if we recall, 2 theta would mean there's 4 petals. We only see 1 petal here. The 3 tells us we're going out to 3, right? So that's good. So yeah, we now need to figure out, okay, which one of these is going to give it to us. And remember, these are telling us the endpoints of this. So for like what we see here, we know these petals, the way they kind of rotate is, you're starting here and then you're going around this way every time. Okay. So we know the two endpoints, the A and the B, have to give us R values of 0 because they end up at the pole. Okay. So the best way of doing these ones is literally plug these numbers into the equation, simplify, and see what you get, and eliminate answers as you go, and then hope you can get eliminate 3 out of the 4, and then you're good. So let's go ahead and start doing this. So I'm going to start with A. We'll do A over here. So A is over here. I'm going to say 3 sine of 2 times pi fourths. And yeah, so we evaluate this. There we go, 3 sine. That's really pi halves. Okay. And sine of pi halves, you may already know at this point, but you could draw I guess I'll have this here for reference. Pi halves is straight up, which means my y value is 1. So that means it's 3. I actually can stop now because pi fourths at 3, it doesn't work out, because you could also plot that point and see that it's clearly not here, right? Pi fourths at 3 would be way out here. A's done. Don't have to check anymore. That point's not on this graph, so I'm good. All right, so now let's go B. So for B, I'm going to say 3 sine of pi 2 times pi over 2. So again, this is for B, which means that's just pi, 3 sine of pi. Ooh, pi is right here, which is -1 comma 0. Ooh, 0 is what this is. So this is times 0. So that's good so far. So this one's a check mark, because if I go at pi halves at 0, I'm right there. Then I can plug in pi. Now we get 2 pi when we plug that in, and 2 pi will give us this point right here, which also gives us a 0 for sine, which means we get a 0, which is what we wanted. So both of these work, where we end up with points right back at the pole, which we want. We want both the endpoints to be at the pole. We should check the other ones just to make sure. It could be possible that we're doing too much and maybe we have extra petals or things like that. So yeah, I'm going to check the other ones just for the sake of seeing it. So let's go C. But right now, B is my best choice. So I'm going to say 3 sine of 3 pi fourths times 2. I forgot the times 2, so I'm going to just write it at the end. So that's going to be 3 pi halves is what that would simplify to, right? 3 pi halves. Hey, that's nice, because that's down here, which is 0 comma -1. And we get -3 as our answer, right? So 3 pi fourths would be out here. Ooh, -1 or -3 would mean we'd actually get here. So an endpoint would give us the point at the end, but that doesn't work out. And actually, the nice thing is we've already done pi, and we know pi works. Pi gives us to 0. But if this is an endpoint and we're going back to pi, that would mean we'd only get half of the petal, not the full petal. So this is why this one does not work. And then 3 pi over 2. Actually, have we checked 2 pi? We haven't checked either of these two. So again, I'm just for the sake of seeing it, because you never know which one it's going to be, I'm going to do all of them. So 3 pi over 2. Hey, this cancels, so you get 3 sine of 3 pi. 3 pi is the same as pi, so it's negative, I'm sorry, 0. Ooh, so that does work. So you get 0. So that 3 pi over 2, 0 works. Let's check 2 times 2 pi. That's 4 pi. And my head's probably in the way right now. So I'm going to do my work over here. 3 times sine of 2 pi, or 4 pi, which is the same as 2 pi, which means it's also 0, right? So when you look at this one, we end up getting an answer that could also work, right? So if this is the case where we have two possible answers, now we have to plug in values in between. Plugging in the endpoints is always a good call, right? So then we have to plug values in between. So now let's check a value between pi halves and pi, which would be 3 pi fourths. Right? That's a really nice one. Which guess what? We've already plugged in, and we know 3 pi fourths will give us a point on here. So that means for this graph, I would start here, go all the way here, hit this, and come back. So that's good. For sake of seeing this, why this one's wrong now is let's plug in something between 3 pi halves and 2 pi, which would be like 7 pi fourths. So if I plug in 7 pi fourths, I know this is so much work. 2 times 3 pi fourths. Okay, I'm going to get sine of 3 pi halves, which we've already evaluated this as -1. So I get 3 times sine, 3 times -1, which is -3. So if I plotted this point, 7 pi fourths, but -3 would be way out here. So that's why this is wrong. And we finally confirm B is your answer. And there we go. Plug in numbers. That's your best way of doing this one without a calculator. Thanks for watching. Have a good day.